Example 2, implicit differentiation. So by viewing y as an implicit function of x, we're viewing y as a function whose formula f of x is unknown, but which we can differentiate. Implicit differentiation, again, is an application of the chain rule. So let's just remember that every time you take the derivative for the first few times until you become more familiar with it. So when you say derivative of basically derivative of y with respect to x, derivative with respect to x of y, then that's dy dx. If you are saying derivative of y to the third with respect to x, according to the general power rule, this is 3y squared, and derivative of inside, which is derivative of inside function, which is y, that would be dy dx. Now if I'm taking derivative of with respect to x of e to the power y, then again it's the chain rule. The outside function is e to the power u, and so that would be e to the power u again, so e to the power y, but you have to take the derivative of inside function, that's dy dx. Now the product and quotient rule will still apply. If you're taking derivative of x times y, first you get the first function times the derivative of second function, so it's x times dy dx. Then you get derivative of first function, which is 1, times second function y. What about when quotient rule? Quotient rule again applies. Derivative with respect to x of x over y is going to be the derivative of top, which is 1, times the bottom, which is y, minus the high, which is x, times the derivative of bottom, which is going to be dy dx over y prime again, divided by y to power 2, which is the denominator. How about derivative with respect to x of x squared, y squared? That is going to be, again, a product rule. It's going to be the first function, x squared, times the derivative of y squared, second function. And derivative of y squared is a generalized chain rule, 2y, y prime. Then plus derivative of the first function, 2x, times the second function, y squared. Another quotient rule, derivative with respect to x of x plus 1 over y plus 1 is going to be the denominator, which is y plus 1, times derivative of numerator, which is 1, minus the numerator, x plus 1, times the derivative of denominator. What is derivative of denominator? Derivative of y is y prime, derivative of 1 is 0. So it's y prime, divided by the denominator to power 2, which is y plus 1 to power 2. And so these happen over and over and over again. What is recommended is to try to do this on your own a few times and make sure that you understand the steps, so when you see them and